All right, so we're going to solve this, but maybe in your head, you might think to yourself, tan of theta equals 1. Okay, I'm using an x over here this time. Whatever, the x could be a theta as well. If you were solving this between 0 and 2 pi, how many answers would you get for theta? Tan of theta equals 1. So between 0 and 2 pi, how many answers would you get? Go ahead if you can tell me, Jason, how many answers would we get?
Would you get 4?
Not 4 for this one. When it equals positive 1 though, specifically. Positive 1. How many times does tangent equal positive 1 between 0 and 2 pi? Could you tell me, Victoria? I think your hand was up before.
Could you, for how many? I think it's 1, right?
Just between 0 and 2 pi. Alice, can you tell me?
2.
2. Shelby, yes. Alice, yes. Okay. 2 times. What angles does that happen at? Positive 1. Where is tangent positive 1? It's positive 1 at pi over 4.
Pi over 4.
Good. And where else?
7 pi over 4.
1, 3, 4, 5. 5 pi over 4 should be. Quadrant 3.
Oh, yeah, you're right.
Right? Because tangent, remember we talked about lines, tangent lines.
Right.
And it has a positive slope. That's where it's positive. So it's here and here, whatever. Okay. So those would be the 2 answers. Now, sorry. When you have your set of answers, whatever the answers of tangent are, and okay, how can I compare this? I wish I had one of these handy. I actually might have one in my apartment somewhere, but I can't think of where. So I brought it from my classroom. You know those balls that people get for like, I don't know, like a birthday party for like whatever decorations, and their tissue paper, and it makes like a honeycomb, and you kind of go shoop like this. I don't know. And it makes the puffy ball. Do we all know what I'm talking about? Yeah. Okay.
Yeah.
So that puffy ball, imagine I have this little puffy ball, and when it's folded shut, it's here like this, the top and the bottom layer. And then I open up the puffy ball, and go all the way around and make the puffy ball. Okay. But if I did what Amelia told us before, it's a compression by 3. Then I'm going to take this ball and I'm going to shut it so it's only 1/3 of the way. So maybe about there, about 1/3 of the way. And that would be able to squeeze 3 of those puffy balls in that circle. Between 0 and 2 pi, I'm going to fit 3 of those puffy balls. So maybe I got like green tissue paper ball, it's here. The next one's pink. And the next one is blue. So I could see 1, 2, 3 puffy balls. I took that honeycomb and I compressed it. So now instead of just having 2 answers on the whole thing, I have 2 answers in my first puffy ball. I have 2 answers in the next puffy ball. And I have 2 answers in the other puffy ball. How many answers will I have all together between 0 and 2 pi? You could shout it out if you think you know. We compressed by 1/3. There were 2 answers in 1 puffy ball. We compressed by 1/3, so now I fit 3 puffy balls in a full circle between 0 and 2 pi. They're all really the same puffy ball. It's periodic. They repeat themselves. So if I had 2 in 1 puffy ball, how many do I have in the whole circle now? If I squeezed 3 in there, how many answers?
6.
Yeah, 6 answers. So you're going to have 6 answers. So the compression, making it 1/3 of its size, that's where it gets confusing, because 3, 1/3, people get weird. 1/3 is how much smaller it got, but 3 is also showing us how many fit in that original size space. So originally it went from 0 to 2 pi, but now I could fit 3 of them. If we compress them all, I could fit 3 of them in that space. So now, instead of having 2 answers between 0 and 2 pi, I'll triple it. You should get 6 answers between 0 and 2 pi. So this is a way for you to reason it out while you're doing a problem, okay? To help you kind of realize if your answer makes sense or not. Did that I could get a puffy ball and I'll demonstrate next time. I'll order it on Amazon. But did that visualization actually resonate with any of you? Can you picture it, or was that too crazy? Thoughts, comments, visualize? No one, no feedback, no words. All right. Anyhow, good chat. It was fine. Like you could picture it.
Yeah.
Okay. At least one person. That's something. So now, instead of me getting theta equals these things between 0 and 2 pi, theta is really 3x. So really, 3x equals pi over 4. 3x equals 5 pi over 4. Okay? Keep going, but let's do a couple things at once. I'm going to include plus, now it's tangent. We talked about it a little bit last time. What am I going to add? I'm going to kind of make this into a general solution. What am I going to add to find other answers to continue this? If pretend it was theta, what could I put here? You're not really wrong if you say either thing, but you know, one of them is just a little bit more efficient than the other, but it's okay. So what can I add over here? Go ahead, Alice, you have your hand up. Go ahead.
Pi over 4.
So you wanted me to put plus pi over 4 at the end? Like I'm going to use the n, kind of like what we did on those earlier examples. Like how I consolidated over here, or I consolidated over here, we put plus 2 pi n, right? What would I put over here? I don't know if you answered, if it cut out.
I was thinking pi over 4 because if you would add pi over 4 to pi over 4, you would get a second answer.
Well, I would get pi over 2 pi over 4. But if I plug in 2 pi over 4, which is pi over 2, times 3, that's 3 pi over 2. Tangent of 3 pi over 2 is undefined, not 1. So it wouldn't give you an answer that works for that equation. Micaiah, is your hand up, or was that from before?
That was from before.
Okay, Zareen, what about you?
Could you just say pi n?
We could actually put pi n. If you put 2 pi, so always, if you put 2 pi n originally, it's probably fine. Tangent and cotangent, though, the period of those graphs is shorter, because if you think about the quadrants, and I think I did this in another example, sine is positive, positive, negative, negative, repeat, repeat, repeat. So it takes a full 2 pi. Same for cosecant, because it's a reciprocal. Cosine, positive, negative, negative, positive, repeat, repeat. It takes a full circle to repeat. Tangent and cotangent, positive, negative, positive, negative. So it's not just because of the signs. It's a little bit more complicated than that, but in a nutshell, it takes pi in length as an angle for us to see the same pattern of tangent repeat itself. Repeat itself. So you can go shorter and just put plus pi n whenever you're doing tangent or cotangent, okay? Now, if I add pi to pi over 4, what do I get for the next angle if this was just theta, not 3x? What's pi plus pi over 4 going to give us? What is pi plus pi over 4 going to give us? Make sure you are getting participation. 5 pi over 4, exactly. You're going to get 5 pi over 4. And that's over here. So what that also does for us is we don't need to list this right now, okay? Like if we were just going to use this, we're going to get that answer anyway, okay? So let's continue. I got to keep going and solve for x. What can I do to everything in this equation to work on getting x alone? What could I do to everything in this equation to work on getting x alone?
Divide by 3.
Divide by 3, but let's multiply by, guys, if you only participated like once in the beginning, that's not full credit. And if you don't participate at all, that's 0. Okay. Claire, what could we say? Instead of divide by 3, we could also say what?
Do you multiply by 1/3?
Yeah, since we have fractions involved, I'd rather think of it as multiplying by 1/3. It's going to help us stay a little bit more organized. X equals, what can I get for this part over here? And then Alice, make sure you put your hand down after you participate so I hear the alert go off when other people raise their hand, okay? What would I write down for the right-hand side over here? Go ahead, Alex R.
Pi over 12.
Good.
N or pi n over 3.
Yeah, but let's even right now in one step, can you rewrite pi over 3n, but with the denominator of 12 already, like in your head, kind of get that ready? No pressure. Take your time. I feel like when you put on the spot, it makes it so much harder.
4
Yeah, go ahead.
pi n over 12.
Yeah, I always say 4 pi over 12, and then I say the n at the end. I don't know. Like,
Okay.
I feel like it gets a little crowded when you kind of, do the n on top too. And then again, if this was written once on your paper already, you're good. So let's go ahead and start filling in integers for n. I'm going to find for part A, my answer is between 0 and 2 pi. If I fill in 0 for n, I'm going to write my solution in set notation. If I fill in 0 for n, what do I get for an answer? If I fill in 0 for n, what do I get as my first answer? Go ahead, Veronica.
Pi over 12.
Good. If I fill in 1 for n, what do I get as the next answer, Carolina? If I fill in 1 for n and clean that up, what do I get for my next answer?
Oh, wouldn't it still be...
If you fill in 1 and then 1 times 4 pi over 12 and then add it.
Okay. Oh, so it'd be... 5 pi over 12?
5 pi over 12. Good. All right, let's keep going. Okay, we said we're going to get 6 answers, so let's keep going. But we're going to look for 1, 2, 3, 4 more. What will tell us to stop listing our answers? If we want answers for part A between 0 and 2 pi, what number in the numerator is telling me where to stop? What number in the numerator tells me where to stop, Victoria?
Would it be 24? Because that's 2 pi.
Exactly. Okay, so we're going to keep going. If we keep adding 4, easy participating right now. If I keep adding 4 to my numerator, give me the next angle. Go ahead, Nolan.
9 pi over 12.
Good. Give me the next angle. Listing them down. Let's go, Amelia.
13 pi over 12.
Good. Give me the next one, Danny.
17 pi over 12.
Okay. Give me another one. Go ahead, KF.
21 pi over 12.
And then if you were to keep going and you added one more of these little 4 pi over 12s, we'd get 25 pi over 12. And we said how the 24 was the edge. Okay, that's where we would stop. And then I'm going to go over here and I'm going to put my little set bracket. So part A wants answers between 0 and 2 pi. But part B, we kind of already have the answer to part B on our paper. What is the answer to part B? What should be written as the general solution, or for all solutions? What is it that we should have written down for part B then? Go ahead, tell me, Makai.
Is it the x equals pi over 12 plus 4 pi over 12n?
Yes, I started writing theta, but yes. X equals pi over 12 plus, if you reduced your 4 pi over 12 and you put pi over 3, that's fine. N, and then somewhere on there, n is an integer. All right, so part A, finito. Part B, finito. You get 6 answers because it took your original answers between 0 and 2 pi and squished it, compressed it by a factor of 3 or into 1/3 of its size. And we were able to fit 3 of those sets in that space, and we squished them all together. That's why we got 6 answers instead of 2 answers. Part A, our finite list. Part B, our general solution. Do you guys have any questions about this type of example? Hands up are, Makai, Jason, I think it's just from before. Shelby, or are we good?
I have a question. So
Sure.
how do you figure out if you do 2 pi over n or pi over n?
So 2 pi n or pi n. by default, if you did 2 pi n always, right? If you're like, I don't know when to use which. If you did 2 pi over 2 pi n, what would happen is you would start with pi over 12. If you did plus 2 pi n, the next one you would get would be 9 pi over 12. The next one you would get would be 17 pi over 12. And then you would keep this example. And the first one you would get would be 5 pi over 12. And if you started adding, the next one you would get is 13 pi over 12. And the next one you would get would be 21 pi over 12. So if you use 2 pi n, you will get all the answers, but you would just leave both equations. Because the answers for tangent were pi over 4 to start and 5 pi over 4. So if I had a full loop, boom, there I am, add a full loop, right? So you're kind of going there. Or by instead of using 2 pi n, we use pi. You could not list this one because adding pi, you'll hit it. Add pi, you'll hit that. So you're kind of consolidating it. So one thing to remember, and I think we might have written it last class, correct me if I'm wrong, the period of sine, cosine, cosecant, and secant is 2 pi, or 2 pi over b, which we'll talk about when we graph. But then for tangent and cotangent, it is pi, or when we start graphing, we'll talk about pi over b. But what the b does is that's like the 3 in the problem. It's the number in front of theta. So when you divide by 3, it compressed it. So 2 pi over 3 or pi over 3 compressed one cycle. So it's like, oh, guys, we have shortened class today because we had a delayed opening. So instead of 60 minutes, we have 40 minutes. We have to take everything we wanted to do between minute 0 and minute 60, and we want to squeeze it into 40 minutes. We're going to compress it into 2/3 of the time. So it's like things are going to have to be quicker. It increases your frequency. If you talked about sound waves in maybe science class, your frequency is increased. It's more frequent. You'll have more of that cycle happening in less time. Okay? So when you're writing those little general solutions for tangent and cotangent, we can use pi to get it started. However, remember, once we divide by that 3 or multiply by 1/3, it does change everything, including the pi or the 2 pi. All right? Hopefully this was helpful. If you're still confused, put a thumbs down. If you got it and you don't ever need to look at it again because you are a master, put a thumbs up. Okay? Questions? We're good? All right, so I'm going to end this.